to start off by thanking the Ionic team for enabling web developers like me an opportunity to develop beautiful cross-platform mobile apps. Keep betting on the web. I'm Alex Walter, CIO at A3J Group. For this session, we're going to take you through how we adapted our suite of mobile apps built with Ionic to wearable technology and a hands-free user experience. The learning takeaways for this session will be we'll introduce why wearable technology is an important next step in the industries that we serve. We'll talk about some of the challenges we faced in adapting our apps for hands-free use, and we'll show some code samples and demonstrate the apps in action. So, physical infrastructure and what we call asset management. It's everywhere and you don't even know it. Think of the industries that are fueling the conversation right now. We're talking about space, pharmaceuticals, infrastructure, energy, transportation, utilities, manufacturing, etc. Asset management is one of the biggest elements keeping those industries moving forward. It is the glue that helps our largest industries focus in a healthy, safe, and successful way. They all rely on heavy equipment to get the job done. Equipment that needs to be maintained, that can break or fail, that needs to jump certain calibration regulations. Like your car or AC unit, these big machines are just as susceptible to regular maintenance and occasional failure. We designed our apps around the idea that most workers focus on specific functionality every day. They don't need to see the full scope of what Maximo has to offer. What they need is a fast and easy way to navigate their task list with a clean, specific interface. We did a lot of research in the wearable technology space before diving in headfirst, and ultimately partnered with RealWear, the makers of an HMT head-mounted tablet unit. What makes RealWear HMT appealing to us is that each HMT runs a version of Android operating system. The APKs can be deployed directly to the device or over an MDM. RealWear actually has their own MDM called Foresight. There's a JavaScript SDK available for HMT units, specifically that allows HTML voiced commands to be attached in Cordova or Capacitor apps. All voice command conversion takes place on board the device, which is really important because this enables offline situations where workers could lose connectivity and still use our apps. We're in an industrial setting most of the time, where Wi-Fi coverage in and around plant situations is not always guaranteed. All right, enough talking. Let's get to it. What we're going to do is I'll turn on the voice activated controls and I will say my programs. What it'll do is it'll launch me into a list of applications here. I'm going to go ahead and say settings. And you can see here, mute microphone. You can see here that what we're looking at is just a standard Android operating system here. Page down, system, about device. You can see mute microphone. You can see here we've got Android operating system version 8.1. I need to update it, I know. But it's a fully functional Android system. Let's go ahead and reactivate, and I will say navigate home. All right, now if I say my programs, I can see all of the different A3J apps here that we've been talking about. The one that we're going to look at is MX Asset. So the first thing I'm going to say is scan barcode. We got a little handy barcode here. Goes ahead and finds the asset that I'm looking for, and I can then say view record 1. Now, what you're going to see here are details about this asset. If I say view history, I can look at all the historical work orders here. Scroll down. So these are just a number of work orders that have been written against this asset in the past. Scroll top. I can also say view attachments and open document 1. Let's see if I've got one attachment here. It's just a picture of the pump. Navigate back, mute microphone. So a couple things here to notice. And what you're going to see is that we've got a few things going on. I'll try and point them out with my mouse. But you can see here we've got icons. These are Ion segment buttons across the top here. But we have not only the icon, but the actual text, which represents the voice command to say in order to trigger that button in that screen. Plus up top, you can see we also have text underneath buttons that would typically be standard navigation icons like the menu button or the back arrow or the next or previous icons on the right hand side. If we look at the app in a standard mobile device, which I'll do here by casting my phone to the screen. Actually, I have a phone in my hand here. Pull this over. So what I'll do is launch MX Asset. And we can even use the native camera to scan the barcode. Go ahead and grab that same asset record. And what you'll see are the differences, right? So up here, we've got the icons with no text beneath. We've got menu buttons and navigation icons up here. These are all obviously standard mobile controls and UI functions that we're able to leverage on a mobile phone or a tablet, right? But you can see obviously some care that we've taken in wanting to put specific voice commands to those actions in our RealWear app. And click on the open book icon and click on the attachments. And you can see here those list items are just standard list items in iOS, right? With none of the buttons, none of the open document 1 buttons on the right hand side that tell you what to say to trigger that list item. You simply touch it as you're used to doing with any sort of smartphone or tablet. Again, we were just trying to keep it as uniform as possible across both of these platforms. Lastly here, I'm going to say enter readings 4. Okay, so what we're looking at here is a thermal camera temperature reading meter. If I scroll down, and I've got the ability to have an extra button there at the bottom. I'm going to say launch thermal camera. Okay. And now I've actually got the ability to look at equipment using a thermal camera. And this is really useful for technicians to see if equipment is running hot, see if there's any particular problems that they might not see with the naked eye. So I can hover my thermal camera here over the image and say, take photo, which will then capture the new reading back into the app. I can say create meter reading, and that reading goes off to Maximo. Scroll bottom, and you can see it registered down there, 118 degrees Fahrenheit. Okay, so mute microphone. That's just a quick demo of what we're capable of. So what I wanted to do now is sort of talk a little bit about what design decisions we made and a few other things to make this happen. Scroll top. So this is a great screen right here and an indicator of what it is that we did. Mute microphone. So if we look at the elements that we have here, I mentioned the Ion segment with the text beneath the icons, as well as the header buttons with the text beneath the icons. And the list, you can see here, we've got buttons on the right-hand side that indicates what to say. So these are just a few of the items that you've seen here, and I wanted to dive deeper into them. So, a couple key decisions that we made very early on. Number one is we wanted the ability to keep one single code base for our apps, regardless of the platform. It's sort of like the mantra of Ionic from the start is you write it once, deploy anywhere, right? So we were really sticklers about having a single code base for all of our apps that we can deploy to iOS, Android, RealWear, the web, etc. Um, the other thing that we were really strong on is wanting to keep a similar look and feel, regardless of whether you were on a RealWear device or a phone, desktop, etc. And the reason is simple because if a technician were to go out in the field with an HMT, we want that experience to be the same as if, let's say, the HMT wasn't available, was in use by another technician or something like that, or somebody had taken it home and forgot to bring it back to work, whatever. They're going to have to use these apps regardless. So on their phone, on a tablet, on an HMT, we could have fully redesigned the experience in a more sort of hands-free, friendly way. But really what we wanted to do was make the experience as similar as possible between all the different devices and device types. So that was a big tenet of ours. So we really try to keep it the same where it made sense. Now you can see there's subtle differences, and the differences are really in trying to just indicate what to say to trigger actions in the system, while at the same time giving that icon feel that says, oh yeah, this is an app, this is a header button. I'm aware of what those three bars in the menu button mean. So I know when I say menu button and trigger the side menu, really what that's going to do. All right, let's get to some more fun stuff here. I want to show a little bit of code. So in our app component TS file, we actually have a little bit of code here that detects if we're on a RealWear device. We're going to go ahead and inject some WearML engine JavaScript into the document. So RealWear has a GitHub repo where that JavaScript is available. There's also an npm package that you can include in your project to download this code in here. You know, due to a whole number of reasons, we have the little wrapper around here where we're going to only include this if we're on a RealWear device. So jumping over to one of the HTML pages, what does that JavaScript do for us? It gives us the ability to attach these data WML speech command tags to any sort of HTML tag that is action based within the application. So if I say, you know, view asset here, that's the speech command that is going to trigger this segment button to fire. So really we've got that data WML speech command tag sprinkled throughout our app. And you'll notice that we just put it in there regardless. It's not harming anything by having an extra tag on a segment button, even if it's on a regular mobile device or tablet. But what we do here is we put a little extra label at the bottom underneath the icon to say if it's on a RealWear device, then go ahead and show the text beneath the button. And what that's going to do is just simply cue the user as to what to say, and that'll be just a world of help for them. Other things that we were able to do were to create some of our own component tags, and those component tags can then be reused across pages and have, you know, their own specific RealWear embedded logic in them. So you can see here we've got the button for moving to the next asset in the header. So we pass the speech command down through the component and into this Ion button. And if we're on a RealWear device, we put the icon as well as the speech command underneath it. Otherwise, we put the icon only. So we've got that type of stuff sprinkled throughout our applications. And then lastly, this is really cool. We took quite a bit of liberty with some of the scroll events. So fantastic API for controlling scroll events in Ionic. So thank you again to the Ionic team for that. But the neat part about it is what we can do is actually add these floating action buttons to the DOM, hide them via CSS, and then tag them with the data WML speech command. And those commands are available to be called, and the methods on those buttons can then fire, right? So even though you don't see those buttons on the screen, you can state the command and those buttons will still fire. So we've got scroll top, scroll bottom, scroll up, scroll down as valid commands across many of our pages. So just a couple interesting little tidbits in looking through the code here. Okay, what we'll do next is we'll actually build an app from start to finish and deploy it to the RealWear device with some of the, we can maybe make a blank starter app, put a button on there that we can actually then trigger using a voice command. So we'll do an end-to-end demonstration here. So what I'll do is I'll start by saying Ionic start, Ioniconf hands free. We'll pick Angular as our framework, and we'll use the blank starter template. We're not going to integrate with Capacitor right now. What we'll do is we'll add Cordova integration, and we've traditionally done a lot of our development on Cordova here at A3J Group, but Capacitor is definitely something that we're looking at moving forward and integrating. There's a lot of great things happening in the community as far as Capacitor goes. Okay, now that that's finished, what we'll do is we'll cd into our Ioniconf hands-free directory, and we're going to say Ionic integrations enable Cordova. So this will just set the app up for use with Cordova. The next thing we're going to do is we're going to say npm wearml and then save it to the package.json file. This is the SDK for RealWear HTMT. We're going to download that into our project, and again save it into our package JSON. Once we've done that, what we can do is now say Ionic serve and actually launch the application in a browser window. It's just a blank starter app, so we'll have to go into the HTML and TypeScript files and make some changes to enable what we want to show. Okay, as the blank starter app here, there's really only one page. It's the home page. I'll open up that home page HTML and we'll just make a couple small modifications here. So we'll say Ioniconf 2021 hands free, and we'll make that our title there. And what we'll do is add a button here with a click event. And let's say when we click, we'll call a method called toast message. And this is the key element right here. We're going to say data-wml-speech command equals, we'll call it make toast. So that'll be what the command that I have to say in order to trigger the click event on this button. Something that we found very early on was how to make good voice commands, right? So typically one-word voice commands aren't good voice commands, we found. And then, more than, say, 3 or 4 words, it struggles to be a good command. We found 2 or 3 words to sort of be that sweet spot for creating voice commands. In this case, we're going to say make toast, and that'll trigger, hopefully, the toast message function. In our TypeScript file now, we'll create a toast controller. We'll inject that toast controller into our home page. We'll make a method toast message. We'll say let toast equal this.toast controller.create, and we'll make our message, what should we make it? Ioniconf. We'll say hello Ioniconf 2021 as our message. All right, duration, we'll put the toast message up for, let's say, 5 seconds. We will make the color the primary color scheme, and then from there make the position equal to bottom. And then we can say toast.then we'll present it to the screen here. Okay. With that, if we were to save all of our files, we should have, you can see here, Ioniconf 2021 hands-free with our Make Toast button in the middle. If we click Make Toast, we get Hello Ioniconf 2021 on the bottom for 5 seconds. Okay, so that's great. Now, the last thing we need to do is to make this attribute actually mean something is inject that wearable package that we downloaded into our app as a script in our angular.json file. So we'll open that up, search for scripts. Here we go. And we'll say node modules wearable engine.js. This is just going to include that wearable engine JavaScript into the app as if it were a script tag in the application. That will do the work of parsing out all of those the data WML speech command attributes in those tags and attaching speech commands to those clickable events. Something that's really important to note here is that when we built our apps, we were not actually doing it this way as far as injecting that wearable JavaScript. We actually copied that JavaScript file into the assets folder in our application and are conditionally injecting it into the app if we detect that you're on a RealWear device as opposed to on a mobile platform. I think I showed that in the previous example, and that's just because of performance reasons, right? We don't want the sort of dumb mutation events that JavaScript file will detect and sort of re-engineer the voice commands as applications change. We don't want that in our regular sort of non-RealWear runtime environment for apps. It's just, again, a performance consideration and something that we decided to do early on. Okay. With that, just need to make a couple of small updates to our Cordova, we'll call this Ionic demo, our Cordova config.xml file. And this is important just as this name here will be the name of the app that we'll have to say in order to trigger the app to fire on that RealWear device. And then lastly, what we're going to do is we use Ionic's AppFlow service. So we'll say Ionic link and create a new app on AppFlow. we'll call it Ioniconf hands-free. And we'll use AppFlow for pushing changes up to it. All right, our app is looking good here. We can change over to that directory. We'll say git add our files here. We'll commit that, and then we'll say git push Ionic master. And this will actually push the repository up to Ionic AppFlow, allowing us to build our app. And then we'll take that APK file that we build and push that out to our RealWear device here. Okay, here on Ionic AppFlow, we have our Ionic hands-free demo, which we just pushed up to Ionic's AppFlow program. We're going to open this up, go to build, and create our first build. We'll select the commit that we just pushed, and we're going to choose the Android platform. We'll run it on the latest build stack and release it. So what this will do is start up a build, and when it's finished, we'll have ourselves an APK file, which we can then take and deploy to RealWear. Okay, now the APK file has been completed. I can click here and download it locally. What I'll do now is I've got my RealWear Explorer here, and I will take this APK file that I just downloaded, drag it here. It's going to install the APK right on the device here, and now I'll be able to say my programs, and you'll see here we have an Ionic demo app on the device. When we open it up, what we'll expect to see is our blank starter template here with our Make Toast button in the middle. And you can see here when I said the command, it went ahead and fired it. So it's super simple to get started with the RealWear HMT. Great device for industry, and really easy to take and build Ionic applications using hands-free voice commands. We're just scratching the surface of what we can accomplish with this technology. We're pushing forward with more Ionic applications, more plugins for native device interaction, and continuing to iterate on the user experience on this platform. Again, thank you to the Ionic team and the great community of developers that have paved the way for us. I hope this session was helpful. Don't hesitate to reach out to me or the rest of the A3J Group team on Twitter. Thanks.